Hi everyone, in this video we're going to go through 3C reflections. So we've already done translations, which is moving left or right, up or down, so you're moving along the axes. Dilation, so you're making the dilating the graph so it becomes wider or narrower. And now we're looking at reflection. So reflections just means it's been flipped over an axis, so either the x-axis or the y-axis. So you can see on the screen we have what looks like a cubic, but I don't think it is a cubic. Anyway, it doesn't matter what it is. You can see how it's reflected. So on the left, we have a reflection in the x-axis. So it's been flipped over the horizontal. And then we've got a reflection in the y-axis. So it's been flipped over the vertical. All right, I'm going to skip these two examples just because we've got heaps of practice questions here. And I've got to keep this video to about 20 minutes. So we'll see how we go. So you can see we've just got heaps of sketching and graphing. So as we move through these questions, I will do some graphing with you just to show you what the graph actually looks like. Okay, so for question 1, we've got the graph of y equals x minus 1 squared. And it's reflected, first of all, in the x-axis and then in the y-axis. Now, with this graph, before you even start doing anything, think about what the graph actually looks like. So we've got a parabola and it's been shifted to the right one. All right, so it's already, your basic parabola has already had a translation. But this time we're going to reflect it. So when we're doing a reflection in the x-axis, let's just get my pen. We'll do part A first. Your coordinates x, y become x and negative y. So if you're wondering where we got that from, all right, reflection in the x-axis and then reflection in the y-axis. You might want to put your own examples in there, but we're going to do heaps of examples together anyway. Okay, so that means the image of x is x, it remains unchanged, and y becomes negative y. So I just need to rearrange that to get the original y. So y dash. And then we substitute it into our equation. So I'll just do that down here so we've got enough space to do. Okay, so y dash minus 1 equals, and then x dash minus 1. Why did I write minus 1? Sorry, I'm getting distracted. I knew as soon as I wrote that, I was getting distracted. Okay, so negative y dash, not y minus 1. All right, so we want to get y on its own. So I just need to shift that negative over to the other side. All right, so there's your reflection in the x-axis, and we'll graph that in a second. For B, we're doing a reflection in the y-axis. So this time, your x coordinate becomes negative. So everything that was positive x before becomes negative, and everything that was negative x becomes positive, basically. All right, so your x, the image has become negative x, so x is equal to negative x dash, and the y has remained unchanged. So let's substitute that in. Gosh, I'm not paying attention. It should be a negative. And I'm just going to redo that without the dashes on the x and the y. Actually, all right, just pause there because I was just thinking we can also write this as negative x. Why did I write exactly the same thing twice? Okay, so negative, and we take that negative out. If we took that negative out, we're going to have plus 1. All right, so when it's written like that, we can easily see the transformations. So the previous one, it's the same thing, but taking that, taking that negative out, I can see it's been reflected, and then it's also had a translation to the left one. So let's graph it. All right, so our original graph is y equals x minus 1 squared. All right, so it's a parabola, as we said before, shifted to the right one. Then we had a reflection in the x-axis, so x minus 1 to the power of 2. So there it is. And then we had a reflection in the y. All right, so remember we took that negative out, so I'm just going to take it out now to show you that it's the same thing. Oops, what am I doing? Oh, I keep writing the wrong thing. All right, and I just noticed if I looked at it, I put the squared on the wrong part, so the square should actually go, let's do another bracket to the power of 2. There we go. So you can see the purple and the green, the same graph. So the only thing is it's easier to see the transformations if you're taking that negative sign out. So I can see it's been, because if you read the green graph, so I'll just get rid of the purple one for now, you might say it's been reflected in the y-axis and shifted to the right one, when in fact what has happened is it's reflected, and it's, if we're looking at our basic graph of y equals x squared, it's been reflected in the y-axis and then shifted to the, actually I probably, and shifted to the left one. So let me just show you y equals x squared, and I'll get rid of these other ones. We're just focusing on this purple one for now. So we've had a reflection. Okay, so when you're reflecting along the parabola along the y-axis and it hasn't been shifted, it's actually the same thing because it's symmetrical around the x-axis. But the plus one just shows that it's been shifted then to the right, sorry, to the left by 1. Okay, so you can see there, it's been shifted. So even though with this green graph, okay, it's the same thing, if you said it been reflected and then shifted to the right one, what you're basically doing is saying it's that. Okay, so it's not the same as that. So just be careful when you're doing a reflection, especially in the y-axis, that the negative is taken out, whatever you've whatever the x is. All right, so just taking that negative out. All right, let's go back to the notes. So, okay, part 2, sketch the graph and state the domain of, okay, I'm just going to sketch these because these are quite interesting graphs because we've got a cubed root graph and a cubic graph. So let's go back to our graphing and get rid of all these ones that we had. All right, so cubic is, actually what did we, let's just sketch it. So let's just do your basic cubic for now. Oops, turn it on. And if it's been reflected in the y-axis, it's going to be, we'll do the x-axis first. So basically we have the negative at the front. So I don't know why it has the same color sometimes. It's really frustrating. How does that? Let's just start again and we'll see what happens. Y equals x to the power of 3. Okay, now we've got a blue one. Y equals negative x. Oh, cool. I don't know why we didn't have different colors before. So there you can see the reflection, and that is a reflection in your x-axis. Now, if I was to do a reflection in the y-axis, your negative goes inside with the x, and then it's to the power of 3. But it's actually the same graph. So the green and the purple graph are the same, because when you reflect in the x and reflect in the y, you're going to get the same thing, because when you're taking to the power of a negative number, it just stays negative. Whereas if you're taking to an even power, so if you've got a parabola or a quartic, it does make a difference, because when you're squaring a negative number, it becomes a positive. All right, so there's a graph of the cubic, and let's do the cube root this time. So, oops, let's just fix that up. And I'll do the cubic. Remember, the cubic and the cubed are inverses of each other. All right, so you can see there that the reflection doesn't matter either. So for a cubic or a cubed root graph or anything to the power of a negative number, not a negative number, sorry, an odd number, you've got, it could be a reflection in the y-axis or a reflection in the x-axis. So you can see there, the blue graph is our original, the green is a reflection, and the way it's written, I would interpret that as a reflection in the x-axis, and then the purple graph is a reflection in the y-axis, but you can see it's exactly the same. All right, let's move on to this one here. State the transformation which maps the graph of y equals square root of x to the graph of y equals the square root of negative x. Now, when I look at this, and eventually, if not already, if the negative is inside your square root, it's going to be a reflection in the y-axis. If it wasn't outside the square root, it's a reflection in the x-axis. So I already know that it's going to be a reflection in the y-axis, but if you're ever unsure, you can always do your mapping. So let me just change that. So y dash. Okay, so we've got y dash equals square root of negative x dash. So I'm not going to rearrange anything. So y equals y dash and x is equal to, whoops, negative x dash. So x dash is equal to negative x. So my, sorry, I shouldn't have written y first. X, y is mapped to negative x, y. So you've got your reflection there on your y-axis, reflected along the y-axis. So if we want to just quickly look at what that graph looks like. Oops, got the Q. All right, so there's your basic square root graph. Let's do a reflection in the y-axis, which is what we just had. Now, some people think, well, you can't take the square root of a negative number, but what is actually happening here with our black curve? You can see they're all negative values of x. So effectively under that radical sign, we're taking this square root of a negative negative. So let's say at negative 2, which is, actually we'll do negative 4 because it's a bit easier to see. All right, there it is, negative 4, 2. When I substitute in negative 4 for x, I'm going to have minus negative 4 or negative negative 4, which gives you a positive number. All right, and then if we're doing a reflection in the, oops, oh no, I did put a negative there. A reflection in the x-axis, you can see that negative sign is out the front. And you can also have both. You can have a reflection in the x-axis and in the y-axis. So think about where that might go on your graph. There it is. Okay, so basically you're getting this negative 4, all right? And when you take the square root of negative negative 4, you get positive 2, but then that negative out the front makes it a negative 2. All right, let's move on. Okay, so find the equation of the image when the graph of each of the functions below is transformed by a reflection in the x-axis or a reflection in the y-axis. Well, the first two we're kind of already done. All right, we did the x cubed, and the next one is the same as x to the power of a third, which we did earlier. So we did do it graphing, and I did say, well, they're both the same thing, and you'll realize that if we did the mapping, so let's just do the mapping for the first one. So reflection in the x-axis means we've got negative y. Don't leave myself much space, do I? So y dash equals, oops, y, get rid of all that. Y equals, okay, so let's substitute it back in. Y dash equals, negative y equals x cubed, x dash cubed. So y equals negative x cubed. All right, so there's your reflection in the x-axis. If I was to do a reflection in the y-axis, I'm just doing this to show you that it's the same thing. All right, so it's negative xy. And the y's don't change. And when I substitute that in, I'm going to have y equals negative x cubed. And because you're taking it to an odd power, it's the same as negative x cubed. So you can see your graph is the same. And I showed you that earlier when I was doing the graphing. All right, with C, we've got a 1 over x cubed. So you still do your mapping, but hopefully by now you will know, well, if I'm doing a reflection in the x-axis, it's negative y equals 1 over x cubed. So it becomes y equals negative 1 over x cubed. And if it was a reflection in the y-axis, we're going to have negative x cubed, which is the same as y equals negative 1 over x cubed. All right, and let's just quickly graph that. We'll get rid of these old ones. All right, so we had 1 over x to the power of 3. Let's add another one in. So y equals negative 1 over x to the power of 3. Okay, so you can see you've had a reflection there along both the x and the y axes. All right, I can't remember which one we did first. What was it? The x axis. And then y equals 1 over negative x to the power of 3. So you can see the green and the purple are the same thing. So when you've got an odd power, okay, the reflections are the same. Where are we? Let's go back here. All right. E is the same as that cubed root graph before. Okay, so D, this time we've got an even power. All right, we've got x to the power of 4. So let's just do some mapping. All right, so we'll do a reflection in the x-axis first. So your x's don't change, and the y. Oops. Okay, so we're going to have negative y equals 1 over x to the power of 4. And then we'll do a reflection in the x-axis. So all right, so we've got y equals 1 over, now we've got negative x to the power of 4. Now, when you're taking a negative number to an even power, that is actually going to become y equals x to the power of 4. So this graph 1 over x to the power of 4, when you're reflected in the y-axis, remains unchanged. So let's have a look at what that graph actually looks like. I probably could get them up. Oh, well. All right, so we've got y equals 1 over x to the power of 4, which is what we just had. And we're doing a reflection in the x-axis, so it'll flip over. There it is. And now if we do a reflection, so it's negative x, remember, and it's to the power of 4. So because it's a even power, all right, it just stays the same as this blue. So you can see the blue and the red aren't the same. Okay, I think that is it for your notes. Okay, I will do a video shortly on 3D, combinations of transformations. There's not too many questions for reflections in your textbook, but just make sure you're okay with the mapping, because when we go on to do a combination of transformations, the mapping will help. Okay, you just can't keep putting things in. All right, you really need to do the mapping, especially if you're not starting with a basic graph. So if you're not starting like with the parabola y equals x squared, you're starting with something more complicated. So the mapping, the practice with the mapping is extremely helpful. All right, bye.